So for real this time, this is the last video for the digestive system. Okay, so I'm going to be talking about three different things. We're going to be talking about swallowing, in this case, vomiting and peristalsis. I'm sorry, not peristalsis, but see, I'm already messed up, and defecation in this lecture video. Okay, so pardon me. There are three phases of swallowing. The first phase is when you actually the initial impulse for you is when you actually push the food back into the back of your, in this case, of your oral cavity in this case, right? So as the food is pushed back, what happens is that is a voluntary phase. That's the only voluntary phase that actually happens, okay? And that is actually you actually using your tongue for that one. However, as soon as the actual, in this case, as soon as the food, in this case, we call it the bolus is because it's going to be circular in shape, it's going to be wet because of saliva. What happens is the uvula, in this case, elevates. And the reason why it elevates, the uvula elevates, is it prevents the bolus, in this case, from actually going back or going up into the nasal passageway. You don't want food going into your nasal passageway. We all know what have happened when we squirted soda out of our noses. Okay, not very pleasant. At the same token, all right, the larynx, which is the voice box, actually elevates. And the reason why it elevates is because you see the structure here called the epiglottis. The epiglottis then closes, obviously, the passageway, the airway, right? Again, you don't want food entering, right, the air passageway. FYI, when liquids or food particles actually enter, okay, that's called aspiration. We know that happens. So that is why we turn our drunk bodies on their side when they are having some issues after having enough drinking. All right. So again, the uvula closes the passageway to the nasal cavity, and the epiglottis, the elevation of the larynx, actually closes the opening to the trachea in this case. All right. Then once, in this case, there's actually a upper esophageal sphincter here, which is shown here, that actually opens initially. And what happens is as the food particle travels, this actually closes, but the lower esophageal sphincter opens. There's actually two sphincters, upper esophageal, or called superior esophageal, and the inferior or the lower esophageal sphincter opens, okay? So then food then enters the stomach, and then obviously once the food enters the stomach, this also is closed, all right? And then digestion then can occur at that point, all right? Now for vomiting, the food is going the other way. We all know this. We've seen it happen. It has happened to probably all of us, to the best of us, okay? So now, the act of vomiting is actually a defensive reflex. Specifically, if it is in this case, especially if this is mediated by this area called the area postrema. The area postrema is in the brainstem, and all it does is it detects toxins. Okay, so if there's a toxin, and this is highly very quick, if they detect there's a toxin in the food particle that you have ingested, what happens is it can induce vomiting. The other thing is the labyrinth. The labyrinth is actually the fancy term for the inside part, your inner ear, the part of the ear that actually in this case maintains dynamic and static equilibrium. We know that as the vestibule and the semicircular canals previously. So the inside part is called the labyrinth. So this is the reason why you actually vomit sometimes when you actually are in a roller coaster ride. Okay? And the labyrinth and the cerebellum is both about equilibrium, about balance, and the hypothalamus, obviously this is about emotions, okay? Or you see something that makes you sick, okay? So that actually can also trigger vomiting. Now, you can also force vomiting, but that is not for this class. So normally food goes one way, but in this case vomiting, the food goes the opposite way, and the reason why that is primarily due to diaphragmatic and abdominal muscle contraction. So it's like someone punched you in the stomach. In fact, if someone punches you in the stomach, you're probably going to vomit anyway, and because of this, the muscles then contract and it squeezes the stomach. And because of the squeezing of the stomach, the movement of food now is called antiperistalsis. Peristalsis is downward, antiperistalsis is upward. Now, vomiting doesn't occur until both the lower and the upper esophageal sphincter actually open or relax. If they both open, vomit comes out, right? And again, this, primarily speaking, especially if this is mediated by the area postrema and the brainstem, is a defensive mechanism against toxins. All right. There's a lot of other things that actually occur here. The respiration stops when you vomit. Why does the respiration stop when you vomit? Because you don't want vomit entering the trachea. Obviously, that should make sense. All right. So that is vomiting. So again, vomiting is just the opposite. And again, there's many reasons why you could actually induce vomiting in a normal fashion. Okay. And then the last thing that we're going to be talking about is defecation. Defecation is basically just a fancy term for pooping, right? So if you've ever read the book Everybody Poops, this would be it. So this is the rectum. So recall that the region upstream, or the region proximal to this area, is the sigmoid colon. So the sigmoid colon, you'll actually have a lot of fecal material in a horizontal or an S-shaped position. So as fecal material enters the straight passageway called the rectum, the walls of the rectum then become stretched because of the amount of the fecal material. So the more fecal material enters the rectum from the sigmoid colon, the more stretch this actually feels. And if enough stretch is felt, okay, this is a reflex, if you want to think about it this way, and this is one of the autonomic activities that is actually mediated by the spinal cord. Okay, so what happens then is there is a feedback, there's a circuit in which a motor neuron exiting from the anterior portion of the anterior portion of the spinal cord then relaxes and it's actually wrong, okay, relaxes the actual internal anal sphincter. The internal anal sphincter is an involuntary muscle. You cannot control that. Okay, so as more fecal material enters the rectum, there's a stretch receptors, okay, that is actually in the rectal wall that sends a sensory signal to the spinal cord, and in return the spinal cord sends a motor signal to relax the internal anal sphincter. Okay, now the external anal sphincter is a voluntary muscle. As you guys can see, that is why this is controlled by the cerebral cortex, specifically the motor gyrus of the frontal cortex, or the precentral, okay, gyrus, if you want to call it that way. So this is the reason why you can hold it in. The reason why you can hold it in specifically is because you can make your external anal sphincter contract. So if this contracts, guess what happens with the anus? It's shut. Okay, when you want to then go and defecate, then it's voluntary. Then you actually send a message, a voluntary signal to your external anal sphincter. Then this relaxes, and then defecation occurs. Okay, so that is swallowing, vomiting, and defecation.